Hi class, this is course 3, lesson 69 on direct variation. We've already talked about direct variation, we just didn't call it direct variation. Direct variation has an equation that looks like this. It's going to be y equals kx, where two variables are proportional, and the constant of proportionality is that variable, that k. It's k, and it looks like it's a variable in that it will change in each equation that's used, but it's still a constant, meaning it doesn't change within the scenario that we're talking about. So here are 3 examples. We have total pay equals $12 times the hours worked. The miles traveled equals 60 miles per hour times the hours traveled. And perimeter equals 4 times the side length. And in each of these are set up just like this direct variation. They are y equals k, 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 k times x. Characteristics of direct variation: when one variable is 0, the other is 0. And so the graph of the equation will intersect the origin. And as one variable changes, the other variable changes by a constant factor. And so the graph will be a line. Okay, to check for direct variation, you make a table and you check for a constant ratio. And here's just some examples to put in your notes. Are any of the following examples of direct variation? A taxi company charges $3 to start the ride plus $2 per mile. The area of a square is the square of the length of its side. The perimeter of a square is 4 times the length of its side. Okay, so this is what you would do in these scenarios. You would make a table. This is going to be the x, and this is going to be the y. So whatever you have solved for, a taxi company charges $3 to start the ride plus $2 per mile, you would pay dollars. And that's going to be based on the amount of miles you go. So miles would be in this scenario would be your x, your independent variable. And you would do the ratio of your output to your input to see if you have a constant ratio. Area equals side squared. The side length will determine the area, and then you find the ratio of, remember these are output over input, and you see if they're constant. And perimeter equals 4s. The chart, you pick your side length, that determines your perimeter, and your ratio will always be constant at a rate of 4 because this is y equals 4x. Okay, just remember that you make a chart to check. You can also make a graph. Okay, so if you have a table of values like you did here, you can graph them, and you notice that this taxi ride doesn't go through the origin, so it's not direct variation. This area doesn't make a line, not a line. It's a curve, so that will not be direct variation. But perimeter makes a nice line, and it includes the origin. So remember that characteristics of graphs of direct variation are quantities which will vary directly. They will have pairs of points which lie on the same line, and the line will intersect the origin. And this varying directly is telling you that your slope is going to be constant. Last slide for you. We have independent variables and dependent variables. Independent variables are your input. They're the first column in a function table, and they are graphed on the horizontal axis, so this way. And the dependent variable is your output. It depends on what you select for your input. It's the second column in a function table, and it's graphed on the vertical axis. The constant of proportionality is the ratio of the dependent variable to the independent variable. Okay, so Jared's going to earn $12 an hour helping a painter. Create a table that shows his pay for 1, 2, 3, and 4 hours of work. Is Jared's pay for hours worked as an example of direct variation? If so, what is the constant of proportionality? So you're going to make a table of values, and so we're going to have, they give us this, right? 1, 2, 3, 4 hours of work. So we're going to put hours, and you're going to have 1, 2, 3, and 4. And then you're going to have pay in dollars. For 1 hour, it's $12 an hour, so this is going to be 12. And this is going to be 2 times 12, which would be 24. And 3 times 12, 36. And 4 times 12, 48. And then we'd want to check to see what is our ratio. Output to input. So it's 12 to 1, 24 to 2, 36 to 3, and 48 to 4, which all reduce to 12 to 1. So, is this direct variation? Well, what happens if you put 0 in here? 0 hours, 0 pay. So it would include the origin. So is it direct variation? So this would be yes. What is the constant of proportionality? Would be 12. And what, if we had to write an equation, what would we write? We would write y equals the constant of proportionality, 12, times x, your input. And you might want to say that y equals our dollars, sorry. Y equals dollars and x equals hours. Or you could have written it as d dollars equals 12 times h hours. As long as you know what those variables represent. Okay, so that's direct variation, kind of quick and in a nutshell. The next lesson we'll talk about problem solving using direct variation, so we'll get some more practice. And with that, I guess I'll see you in class.